Thank you all for being here at this time. I know this is the last session of the day, so I really appreciate. I'm here to present you a very simple IoT architecture that enables the remote monitoring of an archaeological site in Rome. I am Erika Barone. I'm a technical evangelist in Microsoft in Italy. And here in the slide, you can see all my references. So please, if you have any question, feel free to contact me anytime. Well, this is an unconventional scenario for an IoT architecture, actually, because it involves archaeologists, university, and Microsoft. The Mitreo is a sanctuary that has been discovered underneath the Circus Maximus in Rome in 1931 during some works for the creation of a deposit for the National Theatre of the Opera in Rome. The Sovrintendenza Capitolina, which is actually the municipality in Rome responsible for the archaeological site, needed to understand the current status of this site in order to understand if it can be open for tourists and also if the paintings need some kind of a restoration. That's why some universities have been involved by the municipality, and in particular, we collaborated with Politecnico di Milano, which is basically one of the most important universities in Italy for engineers. In the beginning, the project started without Microsoft. So Microsoft has been involved just a few months later. That's why all the hardware stuff has been managed directly by Politecnico di Milano. The team that actually worked on this project is composed of 4 people. One, of course, it's me. Another one is Daniele, my colleague from Italy, which unfortunately could not come here to present the project, but gave a very important contribution. Luca, which is the professor responsible at Politecnico di Milano for this specific project, and Kustab, a master student who presented this project for his own master degree. In this slide, you can see a map of the archaeological site and some sensors that have been positioned inside of it. As you can see, we have different types of sensors. That's because archaeologists needed different type of data. And basically, they choose what kind of data they needed in order to take actions, in order to understand, for example, what kind of restoration process should be applied to the different paintings. We basically have CO2 sensors, humidity and temperature sensors, and accelerometers. Also, the position of the sensors inside the archaeological site was very important because basically archaeologists needed to have the correct data to work on. One thing that I want to underline is that this site is located underground. So one of the biggest challenges that Politecnico di Milano encountered in the first part of the project was related to connectivity. Because basically, having 3G connectivity underground is really, really hard. They tried several hardware and several positions inside the site before finding a correct one. Here you can see the very simple architecture of the project. We have, once again, the different sensors that are connected to a field gateway, which is a Raspberry Pi running Linux. One thing that I want you to notice is that actually the size of the messages between the sensors and the field gateway is small, and also the frequency is very low. The field gateway is a Raspberry Pi running Linux. On this Raspberry Pi, Kustab developed a Python application which basically retrieves the data from the sensors, performs some manipulation locally, and stores the data because of the connectivity issues I mentioned before. This is when Microsoft has been involved in the project. So basically, we provided all the Azure services necessary to transform this data into graphs, into visualization. We created a standard IoT architecture. We used the Azure IoT Hub, Stream Analytics, Azure SQL Database, Power BI, and then a very simple Azure Web App in order to let archaeologists actually see this data. We're going deeper later in the presentation. So, the main challenge that we faced when we, as Microsoft, joined the project was related to the field gateway. First of all, we arrived when a lot of stuff was already done. So the integration with the current technology used was the first challenge that we had to face. We had a Raspberry Pi, we had Linux, and we had a Python application. What we did was installing Mono on Linux in order to be able to run a C# console application, which actually retrieves the data using a TXT file produced by the Python application. So basically, the Python application produced this TXT file as logging file, and we use it as input for to get this data and send them to the cloud. It's important to understand that no real-time requirement in this project, because basically it doesn't matter, okay, if the values are from now or from 10 minutes ago. No worries about that. The second part, the second challenge, was the optimization of the messages. As I told you before, basically, the frequency of the messages from sensor to the field gateway was low, and the size was small. So we needed to understand how to put together multiple data in order to send fewer messages to IoT Hub. And then the data parsing. The data parsing was basically the most time-spending part of the project for us. In the slide, you can see a small part of the TXT file produced by the Python application as log file and used by the C# application as input. I want you to notice that we have in this file different type of lines, okay? We have shorter lines, let's call them standalone lines, which actually have a timestamp, identification number 5, and some values. We have longer line or more complex line, which have, once again, timestamp, identification 4, some values, and this data field, which is made up of different values. And we have another type of line, timestamp, identification 4, just like before, a smaller field data, and then some other values. Basically, the Python application creates the Fourier transformation of the data from the accelerometer. And this Fourier transformation is splitted into 7 lines of this file. In this case, they are one next to the other, but it's not always right like that, okay? So in the parser, we had to identify each line, and we had to understand if the current line was connected to some previous lines. OK, I'm going to switch to the demo to show in practice how it works. Here we are. This is the C# console application that we developed. The first thing that I want you to notice is these get files. Basically, we splitted the TXT log file into smaller files in order to be able to send one single batch event async. Then we read each line of the file and elaborate each line. We're going to go deeper in this. But in the end, what we do is call this method send event batch async, And basically, we send a list of messages we create using the txt file. This is for optimization purpose, because the data have small size. Let's go deeper into elaborate. Here we are. Basically, the first check that we need to make is identify if the current line contains the Fourier transformation. So if it is connected to, it contains identification 3 or 4, then it means that it actually has part of the Fourier transformation. I can show you the file again, just to let you understand. Identification 3, Fourier transformation. Identification, for example, 6, no Fourier transformation. OK? So if the current line contains a Fourier transformation part, we need to understand if it is the first package or if it is connected to previous lines of the file. To do so, we basically need to verify this condition. If the current line is connected to previous ones, it must have the same identification number, the same axis, and a timestamp included within a range of 100 milliseconds. In this case, in this case, the current line is actually part of the Fourier transformation of a previous line. Okay? Otherwise, it is a new one. I want to put a breakpoint here just to show you how it works later. And then the first thing that we did is to check if the lines contains identification 3 or 4. If it doesn't, it is just a simple standalone line. The only thing that we have to do is this simple parsing, and then we create the message that we're going to send later. I put here another breakpoint, and I start the application to see what happens. OK, so we have the first line. Oh. The first line contains identification 5, so it is a standalone line. OK, so what happens? It's basically a simple parsing. It creates this message. It is just a very simple JSON, and add this message to the list that we will send later. Let's go on with the second line. The second line actually contains identification 3. It means it has the Fourier transformation, and it is, in this case, the first line with Fourier transformation for this axis. So when the code comes here, of course, it doesn't find any previous line to compare. And basically, the only thing that it does is adding a new entry in this dictionary with timestamp identification 3 axis X as a key, and packet number 1 and data, the first part of the Fourier transformation, as content, as value. Now, we have the third line. The third line is identification 3 once again, x-axis once again, but packet number 2. It means it is the second part of the Fourier transformation. So what happens when I press continue, it is that this dictionary still has only one entry, but the content of this entry has been updated, packet number 2, okay, and the data is bigger because we appended the second part of the Fourier transformation. We go on through all the lines of the file in this way. I'm going to remove basically all the breakpoints in order to run the application and show you that all the messages will be sent to IoT Hub. Here we are. And we can see very quick messages sent to IoT Hub. Here we have both messages from identification 3 or identification 4 with the complete Fourier transformation, and also the final values, and always packet number 7. Okay? And we also have, it was very quick, so maybe you didn't see that, the simple lines, standalone lines. So now our data is on the cloud, is on IoT Hub. And if you remember the architecture that I showed you before, we have a stream analytics that gets this data from IoT Hub and puts this data into a SQL database. So I can show you the queries. Actually, if you can see them, yes. They are very, very simple queries. We have one input for this IoT Hub and 4 outputs, the 4 tables. Basically, this stream analytics doesn't do any manipulation on the data, any alert. It just gets this data and sends and fills the tables in the database. We just have this data because of the format of the timestamp produced by the Python application. It's just a conversion. So it means that now we have this data on the database. And we use the database and Power BI in order to show this data as graphs. What we did is actually put these graphs inside a very, very simple Azure web app. And as you can see, none of the people that worked on this project was a designer. Okay? This is quite a simple web app, but it's kind of useful. And also archaeologists really appreciate it because it was exactly what they needed. We created these graphs, different graphs, and we asked the archaeologists and also Politecnico di Milano for help because this data actually for us was not really meaningful. We didn't understand how this data could be used in order to take actions, like what kind of restoration process should I apply to these paintings. Apparently, it can be related, for example, on humidity in the archaeological site. So we developed these graphs. We created some filters in order to let archaeologists all over the world to see the current status of the Mitreo archaeological site in Rome. This is a public website, so anybody can access to it anytime. Yes, just to show you a couple of different graphs. Okay, they suggested us to create. And basically, that's it. I'm going to switch back to the slides. OK. I don't have much more to say, actually, but I wanted to share with you some links that you can use if you're interested in this project. We have a link to the Politecnico di Milano webpage, the university, and we have a link with the information, official information about the Mitreo at Circus Maximus. Actually, the second link is in Italian language. I'm sorry about that, but it is the official one. Of course, if you look for Mitreo at Circus Maximus on the web, you can find plenty of material in English as well. Then you can see the Microsoft Technical Case Study, which is the project repo we created with the whole process we've been through for this project. So all the issues we faced, all the problems, and how we fixed it, we solved them, and so on. And finally, the GitHub repository with the source code of the C# console application that I showed you just a few minutes ago. It is a completely open source application. One last request before we go home or to the party. Please complete the evaluation form. It's very important for me, it's very important for us, and also for you to have a better experience in the future. So just a few minutes to complete it. And that's it. Thank you very much.